Hello and welcome to the TelecomTV Summit on Open RAN. I'm Guy Daniels, Director of Content, and coming up now is our roundtable discussion on the emergence of the RAN Intelligent Controller. Yes, it's finally here, the Open RAN component we've all been waiting for, the Near Real-Time RAN Intelligent Controller, or RIC, which promises to give enhanced network control to operators and advance the introduction of automation to their radio access networks. And at the same time, creating a kind of app store for third-party applications. But is the RIC really such a game changer? Well, let's find out what our guests think, and I am delighted to introduce Raj Yavatkar, Chief Technology Officer for Juniper Networks, Sachin Katti, who is Advisor for Strategy at VMware and Co-Chair of the Technical Steering Committee at the ORAN Alliance, and Francis Haysom, Principal Analyst with Appledore Research. Hello everyone, good to see you all again. Thank you so much for taking part in the round table. So to begin with, let's establish some basics. Sachin, what exactly is the RIC?
Thanks, guys. So the RIC stands for the RAN Intelligent Controller, and it was inspired by the SDN movement that a few years back that was happening in the data center and wired networks. So if people recall, SDN was trying to decouple the control plane from the data plane and take the intelligence out of the data plane and make it available as apps on top of a controller that would talk to the data plane using open interfaces. So the RIC is inspired by that philosophy and trying to bring the same level of programmability to the radio access network. So the RIC is essentially decoupling the intelligence that is running out of the user plane in the base stations and the rest of the network, defining open interfaces from the user plane to a controller, which is the RIC, and then providing capabilities and APIs for third-party developers or the operator or the vendor themselves to build applications that can deliver innovative network optimization and automation capabilities. So it's quite exciting. So historically, the radio access network has been very closed, vertically integrated, proprietary. It was really hard to introduce new innovation, perhaps from a startup or into the network itself. So with this open interface, with the ability to deploy apps using an app store-like model, we're really looking forward to the agility and innovation it brings. And we are already seeing examples out there with operator trials, which are enjoying good success.
Thanks, Sachin, and we'll come back and follow up on some of those points in a moment. Raj, what can you add at this stage to explaining about the RIC and defining what the RIC is?
So I think in addition to what Sachin mentioned, I like to draw an analogy to mainframe computers from long time back and how the PC ecosystem with Windows as an open horizontal platform for the operating system opened up the world for innovation in applications in the PC ecosystem. RIC does similar thing. It becomes the operating system for the radio access network by creating a horizontal platform where there are open interfaces to its north to host different applications, X apps or R apps, to be able to add innovation from any third party in the ecosystem. And similarly, as Sachin said, you also have interfaces from the RIC to the DUCU so that you can also use components from multiple parties. Very similar to the analogy I was drawing. So it's really a new control point to open up innovation in the ecosystem.
Thank you, Raj. And Francis, from your perspective, how do you see the RIC?
I like to see it in terms of one of the challenges actually with the technical standards is we can get kind of bound up in the A1s and the E2s of the world, but it's really fundamentally it allows you to allow external control of policy, both on a fast control loop in terms of the near real-time RIC, the ability to control policy that is implemented in the RAN, and the ability to do that on a much longer time scale in the non-real-time, near real-time RIC. So I think it's that opportunity to decouple policy from the RAN. I think the other thing which is really critical about it, it's about the exposure of data and that data being available for everything, both in terms of the near real-time control and in terms of the non-real-time control. So that ability to see the data that is happening within the RAN, and for effectively anybody to be using that. And I think the third characteristic, which we've hinted in terms of the application stores, is very much the ability to not simply sort of code directly, but the ability to effectively plug in modules, the ease with which innovation can be added to this function, the ease with which that can be distributed to many areas, and combined combinations providing innovation.
Thanks, everybody. Great background information there. Raj, can I turn to you again and ask, why is this part of Open RAN, and why hasn't the RIC been present in traditional RAN architectures?
So the traditional RAN architecture, even though it's based on 3GPP standards, has always been controlled by few vendors who built a vertically integrated system. So they could provide all the components together, integrate them, and provide a standalone system. So it's not in traditional vendors' interest to open up that ecosystem and make other players contribute to that. When telcos came together to form this alliance, whole motivation was that they can break open the ecosystem, allow for innovation to happen from small and larger companies at much faster pace, and also bring in cloud native architecture. I would like to give an analogy, right? 2003, there was an attempt made with the CPRI, Common Public Radio Interface. The whole idea at that time was to break open BBU and RRH. But what traditional vendors ended up doing, they ended up building proprietary implementations of CPRI, defeating the whole open ecosystem notion. So this time the operators, through the ORAN Alliance, are being very prescriptive in terms of how many interfaces should be defined, how they should be open, and the third party should be able to contribute modules which can plug in together to create an integrated system. So this is a sea change in the ecosystem that telcos are driving, because it's in their interest to open up innovation, to reduce the cost and increase the pace of innovation.
Great, thank you, Raj. I'm glad you brought up the CPRI experience there. Francis, you'd like to add to this question?
I think it comes down to fundamentally one word: it's software. It's not that we haven't had controllers in the RAN before. In fact, 2G and 3G had centralized controllers. But up until now, we're still very much based on a box-like architecture, hardware-based architecture. Sure, there's software on it, but it's effectively embedded in the hardware. The big change here is software. It's software, the ability to create generic software, the ability to be able to run it anywhere on a distributed cloud is the thing that's allowing the RIC today, where in previous sort of generations that wasn't necessarily the case.
So, Francis, software is a big difference here, but what other advantages does the RIC offer to operators?
I think the fundamental one, it opens the opportunity for innovation, and a secondary area is the area of automation. You at the moment have quite often either you're having to rely on a single vendor RAN to drive your solution, or you're having to separate that usually on a sort of geographical basis by vendor. This gives so you're tending to run each of those as almost separate networks. This gives you the opportunity to actually run your network as a single coherent network, to not just do SOM style, but almost to run the network far more autonomously, and also ultimately multi-vendor, multi-technology, small cells, macro cells, all within a common framework. The innovation one, I think, is the other key one. We generally have a RAN today that is built for mass market broadband, and in terms of legacy, in terms of phone calls, but the opportunities in terms of maybe the low latency services, the mass IoT services, the private enterprise networks, those have very different characteristics and very different needs in the RAN, and they give you the opportunity to provide a faster scale of innovation, better energy characteristics for particular applications, etc., etc. So I think the key thing is innovation and automation.
Thanks, Francis. This is all very positive about what the RIC can offer. Sachin, what advantages do you see the RIC as offering to operators?
So Francis touched on a bunch of them, but I wanted to add a couple more. So as Francis said, it's really about speed and agility in being able to introduce new capabilities into the network. Historically, if an operator wanted a new capability, a new optimization technique or whatever, they had to wait for the product cycles of the big vendors to get them out. So with this, they can experiment with them, try them, and even customize the technique for whatever they want to do. But I think the point I really wanted to touch on was monetization. Right. So as we have all heard, with 5G, the business thesis for the operators is to be able to monetize the network investment using enterprise services. And with the pandemic and remote work and distributed work, it's becoming even more apparent that you need high quality enterprise grade connectivity for people to be able to work from anywhere. So I think one of the things that the RIC offers is, instead of the network being a dumb black box or a bit pipe, it actually it allows you to expose APIs to applications. So applications can get visibility into what's happening in the network and potentially program the network to get the kind of connectivity they need. So really become a platform where the applications and the network are working together to deliver a differentiated experience and allow the operators to monetize. So I think monetization is also a critical component of why the RIC is going to be very important for 5G deployments.
Thank you, Sachin. And Raj, we've heard a lot of advantages and benefits already. Are you agreeing with what you're hearing here? Are there more advantages to operators?
No, I completely agree. I just want to add one more point, which is related to efficiency and cost of operations. Unlike the traditional architecture, even though in a 2G, 3G, there was a RAN intelligence controller, there was a controller available, it was always tied to a single base station kind of architecture. By decoupling the RIC, now you are allowed to have RIC to get visibility and control into multiple base stations in the same region. That allows you to get different type of optimization efficiency, such as slice aware admission control, to be able to look across the region and say, how do I optimize my radio access network? That's another big advantage that operators have, and that feeds into the monetization point made, right? Because once you start optimizing it across multiple base stations across the region of a network, you can also start getting better monetization opportunities by looking at end-to-end applications and end-to-end experience you can offer to the customers.
Great. Thanks, everybody, for those answers. Let's take a look at where we are today then. Sachin, what is the current status of development of the RIC, and what lessons have we learned so far? And admittedly, very early days, but what can we take forward with us?
It's early days, as you said, but I think it's been tremendous progress in a short amount of time. Right. So for context, the ORAN Alliance was born in 2018, and we got the first RIC specs out probably 12 months ago. And we already have alpha deployments at many operators in field trials that are experimenting with the RIC and applications on top. So, for example, VMware has a RIC that just finished a trial at Vodafone, along with partners like Cohere, that introduced very novel massive MIMO techniques to be delivered as an application for optimizing the spectral efficiency. And so there are several such trials that are going on around the world. And I fully expect actually commercial availabilities of some of these RIC products towards the end of this year or early next year to be deployed, and operators starting to take advantage of them in 5G deployments. But I think you asked another question, which is, what are the challenges that we have seen? The challenges, not surprisingly, are getting all the vendors to adopt and expose these open interfaces to the RIC. So this is a collaborative exercise between the operator and the RIC vendors, where they have to work with the RAN base station vendors to make sure that the right interfaces are exposed and the right level of control is exposed, so that all of these applications that are coming on top of the RIC, the XApps, are available for the operator to take advantage of. So that's one. I think the other is, as the product matures, trying to understand how it will interoperate with the RAN vendor. How will we avoid conflicts in control plane decisions between the two layers? How do you do policy management? All of those are natural questions that emerge when you try to deploy a controller in a network. But nothing insurmountable. We have solved these problems in other domains before. I'm certain we will solve them here. It's just a matter of time.
Thank you. Good to hear. Raj, what do you see as the current status of RIC development and what have we learned so far?
So I'm pleasantly surprised at the pace of innovation and acceptance by the operators. We are at Juniper Networks first time entering the radio access network market by developing our own RIC. And we are in trial with 3 different tier 1 operators right now. Where what has become interesting is that we are able to really rely on different DU and CU vendors apart from radio unit vendors, and also bring in third-party XApp providers, RAP providers, so that we can truly start showing a disaggregated architecture where multiple vendors are contributing. We are also contributing our own XApps. For example, as I mentioned, since a RIC can control multiple base units and go across a region, we have our own slice-aware admission control XApp, as well as Slice SLA application. But also third parties like Cohere was mentioned is working with us to provide their spectrum optimization XApp. We have another big company providing their own XApps. So combination of these things are going to be really good proof points over the next 3 to 6 months, where multiple operators would be able to judge and assess how effective this architecture is, not just from purely architecture perspective, but actually being able to increase the pace of innovation and how quickly they can start monetizing the services. So that's something that I'm really pleased with in terms of how quickly we have come to this particular stage.
Great, thank you. And Francis, how are you seeing market acceptance so far?
I think I just take a little a sidetrack here. I think one of the interesting things, I'll come back to my word, the big change here is software. One of the big changes here is the ability, because these interfaces are fundamentally software and not hardware interfaces, they have a degree of flexibility. So that's allowing people to actually be a lot more experimental about the way they're deploying this and ahead of thing. I know for a fact, for example, Rakuten Mobile in Japan has clearly said with the RIC they want to implement some of the standards in the RIC, but they can't wait for the standards. So you've got that kind of almost acceleration in terms of adoption, which may even be ahead of the standard and may also increasingly feed back into the standard as well.
Great, thanks, Francis, and thanks to everyone there for the current status of deployment of the RIC. Now, one thing we've mentioned earlier is that the RIC has been touted as a kind of app store for operators, being able to support third-party apps, the X apps, and we've also got the R apps. Has this model been fully specified and tested? And is it even viable or desirable for operators? Sachin, what are your views on the RIC as a kind of app store?
I think Francis said it right. So the big shift that the RIC is bringing is the software development and agility practices to developing products in the RAN. And I think a key piece of the RIC is building SDKs, software development kits that will allow developers to be able to quickly build applications and experiment with the capabilities that the RIC provides. So we are already seeing SDKs being published. For example, the VMware RIC has an SDK that it makes available to third-party developers, and I believe the other RICs products are also doing the same thing. So I think you're seeing what happened in the cloud, which is the products are trying to make it super easy for developers to build these applications and not have to worry about the complexity of the underlying infrastructure, which typically scares a lot of people away. So I think that's going very quickly towards an app store model. One of the benefits of the app store is the app store just takes care of a lot of plumbing for you, right? So making sure it runs everywhere. You don't have to worry about compatibility issues. You don't have to worry about, do I have the right interfaces and so on. So the RICs are essentially doing the same thing and bringing those app store concepts to the network. Now the question is this desirable? I absolutely think so. Right. So one of the criticisms of the telco ecosystem has been that it has been dominated by 3 or 4 big vendors who have the scale, and it's been extremely difficult for small vendors to enter this because the barrier to entry is they have to build an entire infrastructure. They have to build a base station, for example, right, to introduce a new radio innovation, for example. With the RIC and an app store model, I think you take away that barrier of entry. So all of this innovation that's been happening in universities, a lot of startups, I think it now becomes possible to deliver that innovation in a scalable way without having to reinvent the entire stack to be able to just deliver that small innovation. So I absolutely think it's necessary for the 5G ecosystem to thrive and evolve.
Great, thank you. And Raj, do you agree with Sachin there that this is going to encourage developers, it's going to make developers easier to access the strengths and capabilities of networks?
Yes, absolutely. I think the App Store model that Rick encourages allow anybody, research labs, academics, startups, or even the traditional operators to develop their own applications. One example one of the operators shared with me recently was they have a very well-known research lab. And every time the research lab would develop a completely new algorithm, some innovation, it was hard for them to get one of the traditional vendors to incorporate that into their product because of their slower product life cycles and because of concerns about doing one-off kind of thing for operator. What Rick and the App Store model does is opens it up. And operators are already going along that path. If you look at what they're offering to their managed enterprise service customers, more increasingly they're providing as a service model based on a public cloud model. So they are in that in terms of being able to offer software as a service. And this extends that model by creating an open App Store based ecosystem where anybody can add new innovation, and that innovation can be enabled by the RIC as soon as it's available without having to wait for rest of the components to be developed, evolved, or delivered to the marketplace. So I think we are definitely seeing a very early stage of this new trend and change in the ecosystem, but I think operators are capable of pulling it off. The challenge is going to be that as we do that, if the traditional vendors still come in and try to say combine CU with a RIC and try to offer that as an integrated solution, that will break this model, because I think that will not allow the innovation to happen. And again, the control will go back to the traditional 2-3 vendors who have dominated this market. I think that's the risk in this ecosystem, but that's where the operators have to be very, very specific about how they want to procure different components and allow their integration to happen.
Yeah, very interesting, Raj. Thanks very much for that. Francis, there's a lot of potential here. It sounds very exciting. And is it desirable for the operators? Is this something the operators are really calling out for?
It certainly is desirable, and it's very necessary. I think with the underlying issue here, I think, is not that it's not desirable and it has benefits. I think it's one of culture fundamentally. The operators, there's a synergy between what the providers provide and what the operators take, which is largely based on I trust this thing to work together. So there is a big the big challenge is not the App Store, but it's the whole culture and processes associated with the ability to bring on board new X apps, new R apps as well, new RIC, or all of the other components of the RAN infrastructure, and in fact the rest of the network. So a lot of this, I think, is down to it's absolutely beneficial to have this model. It's the thing that drives automation. It's the thing that drives agility. But it needs to come with that sort of trust environment that I can trust this, I can test this, I can validate this, on the with lots of interacting components. So the opportunity is there, but providing that trust environment, that test environment, that validation environment, constant CI/CD validation environment is going to be key to this.
Great, thanks, Francis. One final question, and Sachin, I'm going to come and ask you this one first. Given the importance and the significance of the RIC, can we be certain that the specification is going to be globally agreed and adhered to? Because we've already heard earlier in this discussion that maybe some operators, can't wait. They've got to kind of preempt what's happening in the specifications work. Is it just the Oran Alliance who's monitoring and developing the RIC here? What's the status?
Yeah, so I think this speaks to the excitement around this aspect of the architecture that vendors and operators cannot wait to get their hands dirty and get going. But that's actually, in my opinion, good news. That means that's real interest. There's a drumbeat of requirements that are coming from all of these deployments. So the Oran Alliance is closely working with all of the RIC vendors and the operators that are involved in this, and we are working to make sure that even though things that are already implemented, are pre-standard, get incorporated in a clean manner into the upcoming standards and that they get supported, as well as new applications. I think one of the good news about the fact that people are racing ahead of the standards is that we are not specifying these standards in a vacuum. It's not theoretical. It's actually being driven by what people are seeing when they deploy this in the field and are facing real problems. And that feedback is flowing back through the standard specifications from all of these folks that are doing these trials. I actually think because of this, we will come out with a more vetted standard, a more reliable specification that everyone can confidently implement, and there'll be less issues discovered after the fact because of that. So the Oral Alliance has two working groups, working group 2 and 3, that correspond to the non-real-time and the near-real-time rigs specifically. And all of the operators and vendors that are part of these trials are engaging deeply to make sure that even pre-standard work that has not been specified is incorporated into the next set of specifications.
Great, thanks, Sachin. Raj, over to you.
Yeah, I think I want to draw a parallel to IETF, which has been one of the most successful standards body that has developed all the internet standards. And right from the start, where I was been very active in IETF for the last many years, IETF set a requirement that any new standard must first show at least 2 interoperable implementations. So when we talk about pre-standard activities or some vendor pushing forward with a pre-standard implementation, I think it's a good news. It makes the standard stronger because now you have a proof point. You also work out many bugs and issues, and that fits into the standard, making it stronger. Secondly, I think having some early adopters of such pre-standard specification also will increase competition and encouragement for innovation. So overall, I think that's good news if you start moving faster towards getting some early proof points.
Thank you, Raj. And Francis, final thoughts from you.
I think I'll come back to the big change here is it's software. Software is much more malleable, much easier to change. You can adapt it on a longer timescale. I think the big thing that will actually drive this is we move the standard process, or we get our culture to understand this is a move to a software standard, not a hardware standard. It was very necessary to define a very hard standards to get hardware to work with hardware. It's a lot easier to evolve that with software. So I think Raj made the IETF analysis. I'd even take it a little bit further. There is no cloud standard, but we willingly use standards to integrate with AWS or Azure, etc. So there's a very different mentality to the creation of de facto standards in that area, and we can learn from that. I'm not saying stop the standard process. And I think the other thing it kind of drives is we probably need to get away from this kind of generational idea of standards. It's the likelihood, is there going to be a 6G? I think it's far more likely to be a constant evolution of the standard over time, rather than we're waiting for another decade for another hard full standard for things as well. So key thing, it's a software standard. It will evolve. It will evolve with people. Interfaces will win because they work and they add value.
Thanks, Francis. And Raj, let me quickly come back to you.
Yeah, I think the one last point I want to make is because Francis is right about software being malleable. But I think having been a software developer all my career, I must tell you that in this particular case, it's not just software. Only the software vendor cannot deliver the final value, because ultimately somebody has to integrate the entire system, validate it. One of the lessons from the failure of OpenStack we know is that when an open standard interoperable people develop purely based on software, system integrators play an enormously important role to deliver an integrated, purely pre-validated system, because ultimately the operators are used to delivering really mission-critical systems which work right from day zero. So even though this is a software-based ecosystem, I must advocate and also warn that, it's not just software alone. You have to have a system vendors looking at it from purely system perspective to allow pre-integration and system integration to deliver really robust products.
Thank you, Raj. And we'll be going into more detail on that exact topic tomorrow on the summit. But for now, we've got to end this particular topic. I am sure we're going to get a lot of viewer questions about this subject, and we'll answer those in the after show. But for now, thanks everybody for participating and sharing your views and opinions. And if you are watching this on day one of our Telecom TV Summit on Open RAN, then don't forget to send us any questions you have, and we'll try and answer them in our live after show program later today. And please do take part in our online poll. You can find it below this video player window next to the Q&A app. All of today's programs will be available to view online here at Telecom TV, and we'll be back tomorrow with more discussions for you. Until then, thanks for watching and goodbye.